sand-sized sediments, sandstones based on sand-sized sediments, etc. We know that chemical comes from evaporated water. We know that biochemical comes from dead organisms, such as coral or bivalves, such as oysters or shells from dead animals. Coquina is a type. Coal is also a biochemical sediment. Realize that crude oil and coal are made from two different things. Coal is formed from ancient swamps. That's where you see ferns and you see trees and you see animals that have died and have basically been in an anoxic state without any oxygen. And they create heat and lignite and bituminous and different kinds of coal. Sweet crude oil is made from microscopic things that live in the ocean. Cachalithophoras, diatoms, those are ancient sediments that make oil. So coal and oil are not created in the same process from the same things. Make sure you understand that. Coal is a biochemical sedimentary product or rock. Oil is not. Coquina is just a type of limestone. I'm sure that you guys, if you've been downtown on Coral Gables, that you've seen how the houses and the government buildings are made from coquina or limestone. That's all right. No problem. If you've ever been to England and gone to the huge white mountains of England, if you look at the cute little people picnicking here in the foreground, and people walking on a little afternoon outing, you look at this entire white cliff. This entire white cliff is made from Cachalithophoras. These are little bitty tiny microscopic plants, protein stuff, that are so small that cannot be seen with the naked eye. So if I were to drop a piece of salt water here on a slide and show it to you, you could count 1,000 Cachalithophoras. And yet that entire mountain is made from what's left of it, from what's left of their body. So there's like 50 gigatrillion. You can count that. Chalk is a type of limestone. The ancient chalk that teachers used to write on the chalkboard was a type of limestone. Okay, let's get into the third type, metamorphic. So when I have a rock that's already a rock, whether it's an igneous rock or whether it is a sedimentary rock, and I increase the heat and increase the pressure, and I change it into something different. So I do a chemical change, then I metamorphize that rock. Just like you get a butterfly that goes through the pupa stage, and then it metamorphizes into a butterfly, and it can't go back. It's the same thing with rock. When you get limestone that metamorphizes into marble, marble cannot go back to being limestone. Metamorphic rock started out as another kind of rock, and it was subjected to intense heat and pressure and created different rocks. Usually, the temperatures have to be high enough to promote or produce chemical changing, but not high enough to melt the rock. So these are special circumstances. And you can't melt the rock, but you've got to heat it up. Now, what are the three things that cause you to partially melt a rock? Right. All three of those lead to metamorphic rocks. If you don't increase the temperature enough, you metamorphize the rock. If you don't decrease the pressure enough to melt the rock, you metamorphize the rock. If you don't add enough water, you metamorphize the rock. So when you take a rock and you start increasing the temperature, decreasing the pressure, and it doesn't melt, it metamorphizes into something else. So just like when you take clay and you put it in the oven and it doesn't quite totally cook, we get different stages of metamorphic rock. Some that have completely changed and some that are partially changed. Or when you undercook a pie and the pie crust is slightly undercooked. It's kind of gummy. You guys don't cook. two types of volcanic rock, two types of igneous rock, volcanic and plutonic. Three types of sedimentary rock, which are plastic, biochemical, and chemical. There's going to be some types of metamorphic rock. Okay? The first type of metamorphic rock is called contact metamorphism. This is limestone here, and it's going to metamorphize into marble. Right? They have similar composition, but the grain size is different. This is what happens when you come in touch or in contact with a pluton or a magma chamber. So, go back to my pie analogy. I told you that a pluton was the stuff, the blueberries inside the pie in the oven, right? The contact metamorphism is the pie crust. So just like the blueberries inside the pie cool to create large grain crystals or to create igneous rock, they're touching really hot rock beside them, and they're changing. They're contacting. So that's contact metamorphism. The second type is regional metamorphism. This is when you have two plates that are moving side by side. So remember when you have a continental plate and a continental plate slamming into each other, converging? You don't destroy continent, you only create new. What happens when you have those two continents slamming into each other? Something's got to give, so it folds and it bends. So you create these long, thin, tabular minerals, or elongated minerals, because you squish it and you bend it. If the pressure, so for example, if you have a tube of toothpaste, and you take the pressure from the top and the bottom of the toothpaste, where does the toothpaste go? Out the sides. If I squeeze it like this, it's going to go out the sides, right? If I take a cake between my hands and I do this, where's the cake going to go? Out the sides. So if the pressure on the rock is coming from the top and the bottom, the minerals are going to be elongated in this direction. If you see the minerals elongated in this direction, then the pressure is coming from the sides. The elongation of the rock is perpendicular to the pressure. So if the pressure is coming in these two directions, the rocks are going to stretch in those two directions. Okay? Make sense? That's called foliation, or the preferred orientation. It's going to be perpendicular to the direction of the pressure. So you know how you take a little kid and you squeeze his face? And the face goes up and down like this? Because the pressure is going in and through. These are so much happening. You gotta take a little humor. Guess what? 3 stars. My favorite slide of the whole class. In this slide, you have this entire chapter. This is the rock slide. So the first thing we have is the 3 major types of rock, which are sedimentaries right here, metamorphics right here, and igneous. Okay? So you can start anywhere on this page because it goes around and around and around and around. But at the bottom, if we start with magma underneath the ground, as the magma comes up and it starts to cool, if it stays underneath the ground, it creates plutonic igneous rocks inside a pluton. If the magma comes up and comes out the volcano and hits the air, it creates volcanic igneous rocks. Okay? Any rock that is subjected to weathering and erosion. Weathering is rain, sleet, snow, wind, anything that breaks down a rock. Then it erodes it and it underlying water. They're called chemical sediments. It's where you get evaporants. If the sediments are formed from dead organisms like corals, bivalves, you get biochemical sediments. All those sediments pile on top of each other, harder and harder and harder. Once they pile enough on them, they are lithified into sedimentary rock. That sedimentary rock, now it can do two things. Number one, it can be subjected to the movement of plates, and you get metamorphic rocks that are formed. Number two, which is called regional metamorphism. If those rocks are just outside the pluton, on the outside of the pluton where the pluton is eating them up, right there inside of a pie, you get contact metamorphism. Because the heat from the plutons on the inside is going to change the rock that's holding it on the outside. So this is the cliff notes of the whole chapter. Can I be any more clear? Want a picture of it? You've got it online, but you'll have to take pictures. So forth. Everybody's good. We're all happy, we understand it, it's not a problem. You guys are drinking before you come to class. Next chapter. So if you're standing in the middle of New York City and you have this big snowball there, and you see the snowball, and it represents a big piece of rock, how do you know what's in the rock? What's in the snowball? You don't. So you start chipping away at it. When this started actually chipping away, look at what you start finding. No. You start seeing French fries. These are all French fries. French fries were actually inside of here. Who would have expected French fries in the snow? When you see the snowball, you don't expect it.